In this video, we will talk about factorial notation, permutations, and combinations. Here are the formulas for factorials. For any counting number n factorial is equal to n times n minus 1 times n minus 2, and so on until you get down to 1. 0 factorial is equal to 1. Permutations. A permutation is an arrangement of n objects in a specific order. Example, a person needs to make up a 4-digit combination to open the lock in the garage door. The person decides to use 4 different numbers from the first 4 digits, 0 through 3. How many different combinations can be made? The person has 4 choices for the first digit, 3 for the second, 2 for the third, and 1 for the last digit. 4 factorial equals 4 times 3 times 2 times 1 equals 24. There are 24 different combinations to be used. Permutation Rule 1. The arrangement of n objects in a specific order using r objects at a time is called a permutation of n objects taking r objects at a time. It is written as npr, or n pick r, and the formula is npr equals n factorial divided by n minus r factorial. So 6 pick 4 is equal to 6 factorial divided by 6 minus 4 factorial, which is 6 factorial divided by 2 factorial. When we write that out, we get 6 times 5 times 4 times 3 times 2 times 1 divided by 2 times 1. So we can cancel the 2 times 1 in both the numerator and denominator, and we're left with 6 times 5 times 4 times 3, which is 360. An example, a radio talk show host can select 3 of 6 special guests for her program. The order of appearance of the guests is important. How many different ways can this be done? There are 6 pick 3 ways to select the guests. 6 pick 3 equals 6 factorial divided by 6 minus 3 factorial, or 6 factorial over 3 factorial. That's equal to 6 times 5 times 4 times 3 times 2 times 1 over 3 times 2 times 1, which is 6 times 5 times 4, which is 120. There are 120 ways to select 3 guests in a specific order. Permutation Rule 2. The number of permutations of n objects when R1 objects are identical, R2 objects are identical, and so on up to RP objects are identical, and so forth, is n factorial divided by R1 factorial times R2 factorial times, and so on and so forth, up to RP factorial, where R1 plus R2 plus so on and so forth, up to RP is equal to n. For example, how many permutations of the letters can be made from the word statistics? Solution. In the word statistics, there are 3 S's, 3 T's, 2 I's, 1 A, and 1 C. The number of permutations is 10 factorial, since there are 10 letters in statistics, divided by 3 factorial times 3 factorial times 2 factorial times 1 factorial times 1 factorial. We cancel as much as we get. We're left with 10 times 9 times 8 times 7 times 5 times 2, which is 50,400. There are 50,400 permutations that can be made from the word statistics. Combinations. A selection of distinct objects without regard to order is called a combination. The number of combinations of R objects selected from n objects is denoted NCR, sometimes pronounced n choose R, and is given by the formula n choose R equals n factorial divided by n minus R factorial times R factorial. As an example, how many combinations of 4 objects are there taken 2 at a time? 4 choose 2 is equal to 4 factorial over 4 minus 2 factorial times 2 factorial. So that's 4 factorial over 2 factorial times 2 factorial. That's 4 times 3 times 2 times 1 over 2 times 1 times 2 times 1, which is 4 times 3 times 2 times 1 over 2, over 4 rather. So I just cancel my 4 and I have 3 times 2, which is 6. Notice that n pick r is n factorial over n minus r factorial, and n choose r is n factorial over n minus r factorial times r factorial. So n choose r is equal to n pick r divided by r factorial. Further, n choose n is equal to 1. One more example. The director of movies in the park must select 4 movies from a total of 10 movies to show on movie night in the park. How many ways can the selections be made? There are 10 movies, and we want to choose 4 of them. So that's 10 choose 4, which is 10 factorial over 10 minus 4 factorial times 4 factorial. We can simplify that to 10 factorial, which is 10 times 9 times 8 times 7 times 6 factorial, divided by 6 factorial times 4 times 3 times 2 times 1. Well, I can right away cancel the 6 factorials, and then I've got a 4 and a 2, which I can cancel with that 8, and then I can cancel the 3 with one of the 3's from the 9. I'm left with 10 times 3 times 7, which is 210. There are 210 ways to select 4 movies from 10 movies.